back. We're going to take a look in the Algebra 2 textbook, lesson 4-6, page 265 is where I'm going to be today. And so I'm going to introduce you to the quadratic formula. And basically going to tell you that this is the way that you can solve any quadratic anytime. It's always going to help you get your solutions, whether they're whole, nice whole numbers, or, if it's fractions or decimal x-intercepts, or if it's imaginaries. The quadratic formula will always work. So the quadratic formula is at the top of page 265, and here it is. It says that to find, remember, we're solving quadratics. We're going to find two x values a majority of the time, all right? Then it says that x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, and all that is divided by 2a. So a, b, and c come from standard form of a quadratic. Remember, the standard form of a quadratic is ax squared plus bx plus c. So if we get a quadratic equation, all right, and we can get everything on one side of the equal sign, then we can just go plug in a, b, and c, and it'll help us find the answer. So I'm just going to jump into example 1. And it says this, x squared minus 10x equals 11. They want us to use the quadratic formula to solve this. For this to happen, everything needs to be on the same side of the equal sign. So I'm going to move 11 over. Remember, when 11 goes to the other side of the equal sign, the sign flips. So I'm going to be right here, x squared minus 10x minus 11 equals 0. Now I'm going to tell you, this isn't going to be the fastest way to solve this one. You could graph it and find the x-intercepts. You could factor and then solve, set your factors equal to 0, and you could solve. So there's other ways to do this, but I'm going to do it with the quadratic formula so I can show you what's going on. All right, so here we go. If you like to come out, something that might help us come out here and write, okay, what is A? A is the number in front of x squared, so that's 1. What is B? B is the linear term, or the linear coefficient. In that instance, that's negative 10, the number in front of x. C is our constant, that's negative 11. So you may want to come write those out. That may help you when you're going and plugging into the formula. All right, here we go. So I'm going to plug in the opposite of B. Now, I like to put my inputs in parentheses. So the formula says take the opposite of b, there's your plus or minus. Remember, we're going to have two answers, or we think we're going to have two answers. It's quadratic. So there's our plus or minus right there. And then the formula says to take b, which is negative 10, and square it. Now, the minus 4 is going to stay there. I'll tell you in a minute what we're going to treat that like, but that's just part of the formula. All right? And then we're going to multiply by a, which was 1. And then we're going to multiply by c, which was negative 11. All right? And we're going to divide this whole thing by 2 times a, and again, a is 1. So there's all my inputs, plugging in a, b, and c into the quadratic formula. Now it's just algebra. Now we just got work to do. You should be able to do it. All right, here we go. X equals the opposite of 10, or excuse me, the opposite of negative 10 is 10, plus or minus the square root of, just do the math. Negative 10 squared, if you like doing it in the calculator, put the negatives in parentheses. Excuse me. Negative 10 squared is 100. Now, the way that we treat this, it's negative 4 times a times c, so I just multiply it that way. I do negative 4 times 1, which is negative 4, and then negative 4 times negative 11 is positive 44, and just multiply all those together. So a lot of people ask, Coach, is that minus 4 or is that negative 4? Since we're going to multiply it through, we're going to treat it like negative 4. And then I'll divide it by 2 times a. 2 times 1 is obviously 2. Okay, got a little to clean up in my radical. By the way, we call this stuff in here the discriminant. I'll come back and teach you a little bit more about that when I do part 2, but just kind of keep that in mind. The stuff inside the radical, or the b squared minus 4ac, is a discriminant. That's going to help us out later on. All right, so I got 10 plus or minus the square root of 100 plus 44 is 144 divided by 2. All right, we're going to keep going. And you don't have to write x equals every time. I mean, you can. I'm just coming down. So I have 10 plus or minus the square root of 144 is 12. Then divided by 2. That cleaned up nice. That was a perfect square. If you're not good at that, do that in the calculator. Just square root of 144. If it's not a perfect square, then you need to simplify the radical like you learned earlier on in chapter 4. All right, so I got two answers here. I'm going to split them up. One is 10 plus 12 divided by 2, and the other is 10 minus 12 divided by 2. All right, so keep doing the math. 10 plus 12 is 22, so 22 divided by 2 is 11. All right, then I got 10 minus 12 here is negative 2, and that divided by 2 is negative 1. Okay, and we find that our solutions are 11 and negative 1. This is something that we are eventually going to have to check. I'm not putting you on that just quite yet. So there's our two answers. There's your two x-intercepts. Like, Coach, why didn't we just do it that way? You're right. That would have been a great way to do it. But I want to show you that the quadratic formula works because, like you learned earlier on in this chapter, there are times where factoring and or finding the x-intercepts in your graph isn't always going to work. All right, I'll do another one of those to make sure we're on the same page. Let's do one where a is greater than or not 1. Okay, I'm going to example 1b. All right, and it's this: 2x squared plus 25x plus 33 equals 0. Now the instructions say solve by using quadratic formula. It's got an equal sign in here. It's quadratic. We got to go find the 2 x's that satisfy this equation. All right, so here we go. I don't have to move anything. It's all moved. So a equals 2, b equals 25, c equals 33. Now those are big numbers, so trust your calculator when we get to that point. We're all right. All right, formula says x equals the opposite of b. I still like to put my inputs in parentheses, even if they're positive. Plus or minus the square root of b squared minus 4 times a times c. Obviously, I didn't have enough radical drawn, so I extended it. That's negative 4 times, that's a 2 right there, times 33, and this is all divided by 2 times a, so 2 times 2. Oh, we got some math to do. X equals, that's negative 25 plus or minus the square root of. If you're not good at any of this, don't be good at it. Let's go right here. We can do 25 squared equals 625. And then I'm going to do negative 4 times 2 times 33, which is negative 264. All right, this is all divided by 2 times 2 is 4. Everybody okay with that? Let's keep going. So let's do 625 minus 264. Get 361. You're like, I don't know if that's a good number or not, but let's check. So I got x equals negative 25 plus or minus the square root of 361 divided by 4. Let's see if 361 is a perfect square. I'm going to do square root of 361. Look at that. Cleaned up real nice and neat right there. 19. That works out. So I got x equals negative 25 plus or minus the square root of 361 is 19 divided by 4. So we're going to get nice whole numbers right here. That's nice. Here we go. Split it up. X equals negative 25 plus 19 over 4. And x equals negative 25 minus 19 over 4. All right. So negative 25 plus 19 is negative 6. So that's x equals negative 6 over 4. This reduces to negative 3 halves. Over here, negative 25 minus 19 is negative 44. So x equals negative 44 divided by 4, which that's negative 11. There you go. There's our 2 x-intercepts. Negative 3 halves, that's a 3, sorry, and negative 11. Okay, quadratic formula, the nice thing about it is it all kind of works the same. You just got to change the numbers. So we're going to deal some more with that. We're going to do some tougher ones and some stuff moving forward that may be a little bit tougher to do, but right now, that ought to be pretty simple for you to work with, okay? So checking that, you can always check and see if the x-intercepts are there, and you can check it that way. But like I said, as we move into the second part of these notes, I'm going to show you when we're going to have to use a quadratic formula, all right? Welcome back from your break. Hope you had a good one. Obviously, as always, come get help as you need help. I'm here for you. Thanks.